So welcome to a glance at the Java Performance Toolbox. Now the talk is going to have a lot to dig into. I hope I can fit everything in. And I'm looking forward to your questions after the talk and maybe take a closer look to what I'm going to show you today. So first of all, a little bit about myself. I'm Anna. I'm currently working as a developer advocate at Oracle. I love Java, and hence the talk of today, but I also love Kubernetes. So we're going to look a little bit into Java and containers and some performance aspects, plus some tools that can help us, take a closer look at it. So that's a little bit about me. As all we know, and we kind of are aware in current modern times, modern applications means running our applications in containers. And, well, Kubernetes is kind of the de facto environment where we run our applications. So we have our applications in the clouds, but we also have a lot of tools that can help us. And oftentimes, we tend to use, the shiniest tools that appear on the market, but we kind of tend to forget a little bit about what is already available within the JDK to help us look at the performance of our application. And the talk of today aims to do that, have another glance of what's going on with the JDK tools that probably some of you already used. Maybe you used them in the past. And it's a good thing to know that you can still use them when you containerize your application. So some questions that developers have, myself included, when running Java applications in containers. First of all, which tools are there to help me make container images with only what is needed at runtime, right? I don't want to make big container images. All the time we aim to make the smallest container images that start very fast, that consume as little memory as possible. So that's our aim as developers. Secondly, how do we run the JDK tools and proxy their output in these containers? Thirdly, how do we capture performance-relevant JVM and application events? So we want to know what's going on with our application, but we also want to know what's going on with the JVM. How do we correlate this, and what can help us get information about this? Fourth, what tools can help us fine-tune the JVM flags and, well, also keep the application overhead at minimum? And last but not least, how do we correlate all these data from the JVM monitoring tools with other tools that are available on the market? And most probably many of you have heard about Prometheus, Grafana, and other widely known tools for working with containerized apps. So we're going to try to answer all these questions today. Now, to start, we probably are aware about a lot of tools to build OCI-compliant images, and probably a lot of us started with Docker build, and what you have here is just what I used, because on the market, there are available kind of 10 tools to build OCI-compliant images. But yes, this is what I've used so far: BuildPax, Jib, Canico, Builda, S2I, and of course, there are many more available to make a container image nowadays. But I guess you all started with a good old Docker file. Can you please raise your hand if you have written or ever touched a Docker file? Good. That's good. Yeah, probably many of you have seen this kind of output before. This kind of Docker file before. And we all have started similar with this when, trying to containerize our Java applications. So our good old Docker file starts with from most of the time, and we all know this rule that we have to use a small base image, the smallest available if possible, so that we keep, the beginning at minimum in terms of sizing. Then we also have to create images that have common layers. So most of the time we're optimizing the layers of our images. We don't want to have a lot of layers. So again, our build time for our container image doesn't take too long. And of course, we shouldn't overuse the instructions in the Docker files. And fourthly, we should install only what is strictly needed. So we don't want to install everything that is in the output of our, let's say, Java application build. We just need to, install maybe put just the jar and some other script that can help us to start it. Like in my case, the entry point script. So let me, show you something about this one. So you see this one is that from OpenJDK 10, GRE Slim. Who of you can shout to me what happened since Java 11 with the GRE? Piotr shouted. Not like that. So Piotr here standing in the front row knows what happened with GRE. Say it. Yeah, so the GRE is no longer shipped with the JDK. That's the thing. And I have a good friend of mine who found out from me last year this detail. He's working with Java 8, and he was shocked, and he's going to say, and he said to me, like, now what I'm going to do. I mean, he was really shocked, and I didn't expect that from him, but he's still working with Java 8. So I'm going to give him this benefit, like, okay. So I tried to explain to him, okay, there are solutions for you to still have your GRE. And he was like, okay, how is that possible? Because it's not shipped anymore. Well, there is a way to create your custom Java runtime for container images using glink, which is a tool to assemble the modules, because as we all know, starting Java 9, the modules are available in the JDK, and we can build modularized Java apps. Well, we can have the modules and only what we need in our Java apps. So glink gives us the opportunity to build our own custom GREs and to have only the modules that our application is needing to start. This is a command line tool to link all the modules, and you can have the modules from a JImage file. I'm going to share the slides with you, and on the link, you can find out what's a JImage. And you can generate runtime images with it. So that's what I'm going to do next. So glink is there to help you package your application. Now, if you're looking a little bit in the slide, in the legacy JDK image, you used to have this, like the bin, the GRE, and the lib. Now, starting with JDK bigger than 9, you have the glink tool that can help you make a modular runtime image, like with a bin, a conf, and everything that you need. But yes, it is great that you can control that, and you can do that by yourself. So let's go back to the good old Docker file. We want to maintain that, the good old Docker file that had the GRE that was already done by somebody, by a third party. Now it can be controlled and maintained by me using the latest Java version. So in my case, I chose to use glink, and I have 2 stages. The first stage is the runtime stage build, where I am building my custom GRE with glink. And then is the application stage build, and we're going to look to each of those step by step and how to minimize, the layers and also what we need to run my application. So the runtime stage build looks like this. I'm using the OpenJDK 19 image from. And I don't need everything from the JDK because my application doesn't use everything from the JDK. By the way, just to tell you a bit, it's a Spring Boot application that is, creating to-do items. So then I have this. I can run glink easy like that, but I need to add modules, right? And some of you are going to say, but how do I know which modules I'm using in my application? Because that's not something you can find out de facto within your application. Luckily, there's another tool that can help you to just get only those modules that you're using, called jdaps. So if you're running this command, I'm going to share the repo and how to run the command and everything, don't worry. So if you're running this command, you can find out what modules your application needs in order to run, to have just that in the GRE that you're building. Moreover, it's good to don't have the debug information from the output image that you're generating. Also, you don't need help or header files. This is what those flags mean. And you would like to have a small image so you can set the level of compression. And in this case, it's 2, meaning zip. So you can enable the compression of resources as you want, like 0, 1, or 2. And of course, my output is streamed to a folder called Java Runtime. This is easy as it is to make my own custom GRE. Next is the application stage build, which can, be the same as before. The only difference now is that I need my custom GRE to run my application. So I'm copying the custom GRE from my previous stage into a location. And then I can continue with my application deployment and copy the artifacts needed in my application and all of that. And you can see that there's something called env JDK Java options. Well, I love that environment variable because I can override it from Kubernetes or I can override it when I'm running my container image with all the details that I want. By default, I set minus enable preview because I'm using Java 19, and I want to use some preview features as well. So, and then run the application. Easy as that. So, looking at this, you can still create your own images and maintain them at minimum. The advantage of using this approach is that you always have a control of what you are putting in your container image on the long run. And of course, you do not depend on others to serve you the base GRE, because that might be a little too much for your application. That's good. That's the good thing. We build the container image. But sometimes when we're running things in production, we kind of realize that not everything works as expected, or not everything works great, and we need to improve. Fine-tuning the JVM flags usually comes when there's a problem with your application. And most of the time, people are very alarmed when there's a problem with the memory. And as probably many of you know, there are two kinds of memory when you're working with Java. There's the native memory, which is the memory allocated by the operating system on behalf of the Java process through C code. And there's, of course, the heap memory, which people are utilizing for their code and for the objects that they build through their code. And of course, issues can appear with memory on both sides, both heap, both native. Now, if you are, thinking about when do I need to know about the native memory? So when would that be useful to track? The native memory is useful to track, as I said, because that's some memory allocated by the OS. When you realize that something is, that your Kubernetes is killing your pods, but your application didn't do anything wrong, to say so, from your application code. That's something that you are starting to wonder, maybe there's some incompatibility from what I said in the JVM with what is going on with my operating system. Because, well, most of the time, what we're having on our local, maybe a Windows machine or a Mac, it's not in the production. So that's when it's good to have tools like jcmd to send diagnostics commands to the application. And of course, if we want to have jcmd in the container, we need to add it as a module. So in this case, jdk.jcmd. That's the only module that you need to add. And of course, you can track your memory by using the jcmd command. I put there a warning because overusing jcmd can affect the performance of the JVM, so you can all the time send the jcmd command just to understand what's going on. jcmd is good only for, let's say, you want to profile certain things. You kind of already had a trigger that something is not going on as well. And secondly, also the native memory flag is something that you should use with caution, because also it adds to performance overhead. But since let's say you have a killer from your operating system, probably you're thinking okay, I need to track these things and see what's going on. And if you're running in a Kubernetes environment like here, you can easily set it as an environment variable through the JDK Java options that I showed you earlier. What is good to do to have all these? You can have a native memory baseline using the native memory. Again, with using the jcmd and using the virtual machine ID, that's the LLM VM ID. So you can create a baseline at some point, like a snapshot of what happens with your native memory at some point, and then have a diff between that snapshot and what happened over time until you took the diff. But those being said, let's go a little bit here and look at the application. So as I said earlier, there's just a simple Spring Boot app. And because I needed a way to have my application working in a container, but also with Prometheus and Grafana, I have created a Docker Compose. So this is my Spring Boot to-do service, all together with a Prometheus and a Grafana, working in a containerized environment. Okay, let's start it first. Docker Compose up, -- build. It's going to take a little while. So let's look a little bit at it and what can we do with it. As I said earlier, we can use jcmd to look and send diagnostic commands to it. And I have for that my track script, where I can just do a docker exec in my container to get the memory baseline. How do I know that is one, the VM ID? Well, that's the ID that it gets by default when it starts in a container. It's the only virtual machine in my container. Okay. I think my Grafana didn't work as expected, but we'll see later. Good. Let me just put also some load on my application, and let's see what's going on with it. So first of all, let's look at the flags and look what's going on with the native memory. I'm going to run my flag.ch script because it has all the jcmd commands. So first of all, let's see what flags are there. So if we want to know what flags your JVM is running on, you can use the jcmd lmvmid and vm.flags. And these are listed as output in their alphabetical order. So if I'm looking for native memory tracking, it's not here. And well, I also have the command to run the jcmd to see native memory, and says native memory tracking is not enabled. Because I don't know all the flags by heart and all the values, jinfo is there to help you as well, and is a good tool to help you with that. So I also ran jinfo -flag native memory tracking and the ID of my VM. And I get the name of this flag here. So let me enable this in my Docker environment, JDK Java options. It's going to be more stuff. Native memory summary. And let's start this again. Oh, sorry. Thanks. Thank you. Such a nice audience here in the front row. Docker compose up -- build. So build everything again. Okay. This looks like Grafana is doing better now. Let's run again the flag script. .ch. Yes. So now I can see that my native memory is being enabled. Yes. And you can see that everything's up there, up and running, and how much memory is being, native memory is being consumed, and so on. Now, while your application is being running, you're going to see that the native memory is fluctuating because the garbage collector, of course, is working. So you're going to see like an increase and a decrease in memory. If you see that there's just an increase and they're not decreases, that's when you should be alarmed that maybe something is not garbage collected properly, and maybe you should look more that maybe you're having a memory leak or something like this. But that is one way to look at the native memory. And this is about the JVM and interaction with operating system, right? But what if it's something related from what you created as your own code? That's not going to be shown here in this code. That's something you can see with a heap dump. With a heap dump, you can get it from jcmd again, or you can use other tools like jconsole, for example. So let me just have my jconsole here and reconnect to my container. Hopefully this is it's not the biggest in the world. So from jconsole, if you go to mbeans, you can create your own heap dump. From hotspot diagnostic, operations, dump heap, and I'm just going to say recordings, dump.hprof, and usually just an enter. Yes. Oh, I ate a P. Thank you. So when the heap dump is being invoked, that's going to be dumped on my local system. Let's look at here in recording. So I have the dump.hprof. And looking at what is available there, you can have multiple tools to analyze your heap dump. But if you're looking at what's going on within your application, you can see the biggest objects that are being allocated. I mean, the objects that are eating most of your memory and how that happened, how much of that they're eating in IntelliJ or in other tools. I mean, the profiler in IntelliJ is quite helpful and quite good in looking at the heap dump without, leaving the IDE. Besides these, what I want to tell you is that I managed to connect with jconsole to my remote container by enabling JMX. And if you want to enable JMX securely, you have to set a few things. Because we have a few folks here from, well, there's Jamie from Sonatype and he's probably preoccupied with security. This is what you should set up if you want to access securely a remote host and not, disable security and just go with the default. So unfortunately, you have to have a key store password. You have to have a key store. And of course, you have to authenticate to that connection before, doing anything with any remote tool. How can you get more about your running Java processes? You can also get statistics for your Java running processes by using jstat. So jstat, as the name says, can get you information about what happened with your running processes. There are two tools, jstat and jmap. And for them, I can also run a few scripts for that. Let me just see if it's track. No. It's query, yeah. So the jstat can query how the garbage collector worked. And this one is querying for 25 samples at each 250 milliseconds. And the H10 here that you're seeing, it means every 10 samples, please put again the header of what is going to be there in the output, because you would need it. And I'm going to show you in a moment why you need the header. So let me just run this. Yes, I want to print the heap summaries as well. Okay, let's look first at GC stats. So this is going to be a lot of information for you to look into. But what you should look into in such a file or output generated by jstat is for the moment when the garbage collector is in action. And usually you should look on this column of idle space and then old space, what is promoted from idle space to old space, how much time did it take, and of course, how much space is being used after the garbage collection. And usually you can identify that when there is a zero going on, and this is the zero moment, when the promotion happens. And you can see why the header was very important, because I need to know which column is idle space, which column is old space, and when the promotion happened, so that you don't get lost when you are collecting the statistics about garbage collection. So you can see that the garbage collection happened here, and that it took 17 milliseconds from what I'm seeing here. When you see that the promotion takes a lot of time to happen, and there's a big pause in garbage collection, again, you should be aware, or you should be alerted that something must be not going on with how the garbage collector is working. Again, maybe memory leaks or something is not, correctly, collected and deallocated within your code. And the other one, the heap summary from jmap, it gives you a summary of the heap and how many instances and how much bytes they're using by object there. Usually, if you're seeing one of your resources, one of your objects that you created, having a lot of instances and a lot of space, again, memory leak or something, it's not okay with how your memory is being deallocated with your Java program. Now we get to the last part of it. So how do you capture all these informations that you see in profiling your application and make them a good connection between what's going on in the JVM with your other application events? And how do you see them in Prometheus, for example, or in Grafana? So you can do that with JDK Fluoride Recorder. And by having JDK Fluoride Recorder added to your container, you can do several things. So you can enable this one for your Java application and profile your application. By profile means you're starting a Fluoride recording, and you can stop that Fluoride recording. You can dump that recording and analyze it furthermore with Java mission control, JDK mission control, sorry. But that's something that you can see as something when already are alerted that something is wrong, and you can like focus on things that are not correctly working. But luckily, JDK file recorder has something called GFR streaming. So GFR streaming is very useful when you want to stream selected metrics to your monitoring service. In my case, it's Prometheus. You can send averages, min, maxes, or everything that you want to do on a metric. And you can expose this GFR data to other management APIs as well, so in the example here. Like if you have like a remote recording stream. And you can have this in your Java code very easily done. Let's go here. When not to use GFR streaming. So GFR streaming is when you want to collect metrics continuously for your application. Now, starting a recording, stop a recording, and having it on the disk for analyzing, as I said earlier, is for profiling. De-streaming is for the long run. So you don't want all the time to like start, stop, have a recording, look at the recording, and then get more information about monitoring from the recording. You can have information from the streaming API without any stopping or dumping any information about the recording. So let's look and see how we can implement that in Java. Because I have a Spring Boot app, I want to have my my GFR events captured after my application has started. So I have done this very simply. 1 second. On an application startup filter, let me make this bigger, that implements the application listener for application ready events. So when my application is ready, I can easily capture the GFR events that I'm interested in. In my case, I'm interested in the heap summary, the CPU load, and the garbage collection, only these three. By the way, you shouldn't like expose everything as a metric from the GFR just to have it all. You just have to get information about what's needed. In my case, I just want to know how the heap is doing, how the garbage collector is doing, and how is the CPU load. And let's do that. So the way to do that, as explained earlier, is like to try and open the repository on the event stream. Then you can use the event, and on the event, you can add now the name of your event. So in my case, I think, sorry, there's this one, JDK heap summary that I haven't captured yet. So JDK heap summary, and then on the recorded event, I want to be able to send this to as a metric, and then query this in Prometheus. So I'm just going to use a builder. And I want to just give it a name, JDK GC heap summary. Maybe give it some more details. Heap used. Sorry. Okay, heap used. Now I also need, sorry about this to the, all right. Then I need to get some information from this event. I need to go and say recorded event, and then get an information from what's there. So I think I was interested in getting the heap used. Yeah, get long, and this is a long heap used. Okay, let me see if I need anything else for my, no, I don't need anything else for my gosh. Once this is being done, the event is going to be published, obviously, in my application. So if I'm going to api.prometheus, did I stop this? No. My application should be running. 1 second. Oh, I also need to enable something else for GFR. So if I want to, use the GFR streaming, of course, I need to start GFR. So in my Docker Compose, I need to add this. I'm just going to copy paste this in the interest of time. -x, I start flight recording. I can also add the flight recording, the file name, if I want to capture recordings. But if I don't, I can use my own settings, and I can dump all this on exit. And of course, the max age of what I'm gathering is 5 minutes. Okay, let me save this. Docker compose up -- build. Let's see. It's starting. Takes a while. But I always wanted to be like from the last change that I did there. Didn't expect it to take this long. So the idea is that after that is going to be started, is going to be my metric is going to appear under API Prometheus, and I can see it very nicely in Grafana or Prometheus and correlated with the number of requests sent and how much those took, for example, and look at each those by comparison. Okay, let's start. Seems to be doing something. Come on. Oh, yes, I know what I did wrong. It was actuator Prometheus. Duh. Sorry. Yeah, Spring Boot. Didn't use it a little bit for a while. So my metric was JDK heap summary used is here is the bytes allocated by the objects in the heap with what I created. And you can see it's exported to Prometheus through here. So I can consume it in Prometheus easily. I can even look in Grafana to what's going on with my application and like have Prometheus there as a source and see some nice graphics. And you can see how the application progressed through time in here. So you can see my recently JC heap summary used in comparison with the amount of requests that were sent, and of course how the heap was used when these amount of requests were going on. I also have a similar graphic for the CPU load. That's another metric that I'm already externalizing it to look at how much CPU load was there on my HTTP for the HTTP request on different endpoints. Those being said, you can create also your custom GFR events. You can have by making your own settings, by extending the setting control. So if you feel that there are events that are coming with GFR that are about the JVM are not enough, and you want to capture your own about your own application, and maybe what Micrometer is giving to you is not enough, you can also create your own with the GFR events by extending the JDK GFR.setting control. Then you can create your own custom event by extending the event, a JDK GFR event, and you can register that custom settings in your event via the JDK GFR settings definition. Now, because I'm using a Spring Boot application, what I did, I used the flight recorder filter to for my custom event settings. So this recorder filter is being added when my application is being started. And of course, I'm listening to the custom GFR events and record their duration via some metrics. And I'm using a custom metrics listener for that. So that's a servlet listener that I'm having, and where I'm gathering all the metrics that I need about my custom event. That was it. This is where you find the code. And I am looking for your questions because I think we have like 10 minutes. And by the way, the code does have a memory leak that I couldn't replicate it in time for today. And if anybody of you will spot it, I'm looking forward to discuss it with you. So it's a catch. It's a catch on that one. Yes, I'm looking on it's a very interesting catch on memory leak. So yeah, maybe some of you already have pod at these kind of things in real life, but yeah, I'm looking forward to seeing that. It happens after 1 million of records are being inserted. It took a lot of time for that to happen on my local, so yeah. Any questions from the audience? Okay, everything was clear. Oh.
Have you maybe measured the impact if we activate these kind of analysis tools in the running JVM?
So for GFR, I know that the impact is max 1%. If you're like using just enabling it and you're not dumping constantly or doing all these things. As I said earlier, for jcmd and for native memory tracking, they do have performance overhead. That's why the caution on using them. So usually people are activating the native memory tracking, not by default in containers. That's why it's not activated by default in my container as well, like inside the Docker file. I don't, and yeah, you kind of activate it when you identify that you have a problem. And typically, you can see the problems, like looking in these kind of tools in Grafana, having alerts and all this, because they look at the metrics overall in time. So you get the alert that something is not going okay in time with your application, and then you start profiling what's going on with your application. But yeah, that's kind of the documentation overhead of these tools. JFR so far is okay from my point of view of having it enabled and have streaming the what's going on with your JVM. Any other question?
Thanks for the demo. I really enjoyed it. I was wondering which of the tools are available in OpenJDK as well.
All of the tools are available in OpenJDK except Prometheus and Grafana. You need to have them from other locations. So all of them are tools that are available in the JDK for a long, long time. I think G-Link is one of the latest additions to those tools, like latest because it appeared with Java 9, but the others have been there for so much time. And a lot of them do not require you to add them as a module. So for example, JInfo, jstat, and these there are some tools that are by default included in the base, so you don't need to add them as a module. jcmd, JFR, you do need to add them as a module. Welcome. Any other question? Yes, there's a.
Thank you from my side also for the demo. A real-life question maybe. So you're working on a Kubernetes cluster, you're deploying your pods and everything. Would you, if you are looking for problems, would you enable these tools on all of the pods or only on selected pods? So for example, you have 4 or 8 pods deployed for a microservice. Would you enable it on 1 or 2 or 50% or all of them if you're looking for problems?
So a number of pods, they're scaled. So usually, if you're enabled at deployment level, like they would be enabled on all of the pods that are scaled with the deployment.
Exactly, that's the question. Would you enable it selectively or on the deployment itself?
I would enable them on the deployment itself, but as I said, because you don't know which one of those pods is causing the issue, so you kind of need a little bit about all of them. At least that would be my take, to look at all of them until I found out which one is problematic. If you want to enable them at pod level, yeah, you can do it at pod level, I think, as well, but that would be like after you realize, that would mean, no, I still would do it at deployment.
Okay, thank you.
Welcome. Because, for example, in case of memory leaks, if one of the pods get killed before others, for example, you would still need to track all that. So, and recreate it, and yeah, you still need to do that. And also in Prometheus, it would be cool to get all the details via streaming, like which one was killed, when, like you would see when's the gap on the instances that died. That's a great question, by the way. Any other questions? Okay, in that case, you can find me here until the end of the conference. I'll attend some talks as well, or you can ping me on Twitter. It's okay, everything's open and in my DMs. And I'm looking forward to talking with you after the talk as well. Thank you for coming to my talk.